Dear students, I welcome you to my video lecture. I'm your course instructor, Dr. Mazullah Khan, and today we will cover part of chapter number 7. So, in my first two lectures, we covered the first two learning outcomes. I talked about the internal rate of return, and then in my second lecture, I taught you how to calculate internal rate of return. We used spreadsheet like Microsoft Excel, okay, and we calculated the internal rate of return through solver, through spreadsheet function, which is IRR, and of course your cash flows, and then you had to guess. You have to provide a guess number. And then we used interpolation. Let's say if you are calculating the internal rate of return with your hands. In my last lecture, I told you that mathematically it is close to impossible to find out the internal rate of return. Internal rate of return is one of the analytical tools. So if you remember, we used PW and AW in chapter number 6. In PW and AW, interest rate is given, and we were required to calculate present worth and annual worth. In internal rate of return, instead, PW is given, and we are required to calculate the interest rate. Okay, so by definition, IRR is the rate at which your PW is equal to 0. And similarly, AW equal to 0 or FW is equal to 0. Because whenever PW is 0, of course, the annual worth will also be 0, and the future worth will also be 0. So it is exactly the same thing. It doesn't make any difference. So IRR is an analytical tool that we use for project evaluation and then project selection. And how do we make that decision? We accept those projects for which the IRR is greater than or equal to minimum attractive rate of return. And of course, we reject those projects for which the internal rate of return is less than the minimum attractive rate of return. And it makes really sense. Minimum attractive rate of return is the rate which the management requires at minimum. So this is something that the minimum that the management requires. It is the minimum threshold. Okay, that's why we use MARR, what we call as a cutoff rate or threshold for project selection. And as I told you that IRR by definition is the rate at which your PW is equal to 0, FW equal to 0, or AW equal to 0. Now IRR is simple to calculate for conventional cash flow diagram, cash flow series. And how does a conventional cash flow look like? Okay, so this cash flow diagram represents a conventional cash flow series in which we have an initial investment, and then the remaining cash flows are actually inflows. Okay, so we start with an initial investment. Normally we call it the first cost of the project, and then of course we are hoping to get some return. The conventional cash flow diagram series, the way it is defined in the book, actually it says that if the cumulative cash flows starts with a negative number, like cash outflow, and then it changes sign only once, that is a conventional cash flow series. But let's say if the cumulative, so please pay attention to this word cumulative. Okay, so it has to be a cumulative cash flow. Okay, not a simple cash flow. And I'll show you how do we calculate the cumulative cash flow. It's super easy. Okay, so whenever a cumulative cash flow starts with a negative sign, which means it starts with an investment, or in other words, cash outflow, and then the cumulative cash flow changes sign only once, that is a conventional cash flow diagram. On the other hand, let's say if it starts with a positive number, or if it changes signs more than once, of course the cumulative cash flow, then it's a non-conventional cash flow series. And in this coming few slides, we will learn how to, because there are some problems. Let's say if the cash flow series is non-conventional, then we have a problem of what we call multiple IRRs. So let's take example 7.3 from the book. As you can see, the cash flow started with minus 400,000 initial investment, and then we are getting $75,000 each year, okay, until year number 9. Some of the projects actually involves a huge, what they call phase out cost, okay. So nuclear projects, whenever those projects are completed, the environmental standards of certain countries require a huge investment in order to dismantle those projects. Oil and gas fields, once you construct, let's say, erect any facility or any, let's say, on the oil and gas facility, after the exploration is done, once you are required to dismantle those facilities, it requires a huge investment as well. So for those projects, you will see a large amount at the end of the project. Okay, so these are cumulative net cash flows. The first cost at t equal to 0 was minus 400,000. After we receive an inflow of $75,000, my net cumulative cash flow is minus 325,000. And as you can see, with every inflow, my cumulative net cash flow is actually decreasing, of course, but with a negative sign. At t equal to 6, as you can see, it changes sign. Okay, so initially it started with a negative sign, but now it changed sign. So from minus 25,000, it is now plus 50,000. Okay, 125,000, 200,000, 275, and $50,000. So as you can see, the cumulative cash flow changes sign only once. Okay, it will have certain implications. If I calculate the IRR of this cash flow, of course, the way it works in Microsoft Excel is it's IRR, you provide the information about the cash flows, and then you provide a guess number. So the significance of this guess number is that the computer starts calculation and takes this guess as a reference point, So as you can see, if I provide a reference point of minus 20%, the computer is trying to find out IRR, which is close to minus 20%. And of course, IRR by definition is the rate at which the PW is equal to 0. So if I plug in minus 18.70, my PW for this cash flow will be equal to 0. On the other hand, if I provide a guess of 10%, the computer is trying to find a solution of 10%, a solution of IRR close to 10%. In this situation, it returns a value of 4.53. Now, if you graphically see and do the same exercise that I covered in my last lecture, if you plot the present worth of this cash flow series by using different interest rates, okay, you will see a diagram like this. And you can visually see that there are two IRRs, because we can visually see that the present worth at these interest rates is equal to 0. So we have actually more than one IRRs. Now my real problem is, which IRR should I use for my project selection? Okay, and we will learn about these techniques. Okay, let's take another example. Example 7.4. This is another cash flow diagram. These numbers are multiples of $1,000. Okay, if I find out the IRR by, it's a spreadsheet function, one of the IRR is 7.47 and the second IRR is 41.35. The reason I'm contrasting example 7.3 with 7.4 is you can see that one of the IRR in 7.3 is minus 18.70. So one of the IRR is negative. Okay, so IRR number one was negative and IRR number two was actually positive. But we may have situations where both the IRRs are positive. And also we can also see the IRRs after plotting the present worth of the cash flow series for different interest rates. And as you can see, it is all positive. Now, there are some special considerations for IRR. One of the considerations that we already covered in example 7.3 and 7.4 is the existence of multiple IRRs. So this I hysteric refers to IRR because I hysteric is a rate at which your PW is equal to 0. So depending upon the sequence, so why do we have multiple IRR at all? So depending upon the sequence of the net cash flows and outflows, there may be more than one I value. Okay, and how do we know? Like for example, if I look at a cash flow series, can I tell right away how many IRRs does it have? We can certainly do that. There are some techniques for it. Okay, so we will learn about that. The other consideration for IRR is the reinvestment at what we call IRR. So present worth, annual worth, I is given. I is given. And that I is normally the minimum attractive rate of return. But let me give you an example. Suppose instead of PW and AW, I'm going for IRR as my project evaluation and selection tool. Okay, and for example, in one of my examples, as you can see, the IRR is extremely high. It is 41.35%. Okay, there are hardly any projects where I can expect a return of 43%. Okay, in IRR, if I'm using IRR as a tool for analysis, what my assumption is that I have the ability to reinvest my positive cash flows at the internal rate of return. Okay, so the whole point is, for example, let's say if I have cash flow diagram, let me draw it for you. So 0, 1, 2, 3, and 4. And for example, there is an initial investment of 10K, and I'm getting, let's say, 3K. So this is cash inflows, okay? So 3K, okay, for each year. There will be an internal rate of return, of course, but in order for me to discount this $3,000 for at a rate of IRR, it really means that I have the ability, the built-in assumption is that I have the ability to invest these $3,000 at internal rate of return. Because what it really means that, let's say, if I'm getting this $3,000, normally the company do not sit on this $3,000. They invest it. So they get this money from the project, like the $3,000, and they invest it somewhere. Okay, they get, let's say, this $3,000 at year number 2. Of course, they have some plans to invest it. Year number 3, they get $3,000 and they have some plans to invest that money. In IRR analysis, what the built-in assumption is that the company has the ability to reinvest those cash inflows. Okay, so for a very high internal rate of return, for example, if I take example 7.2, one of the internal rate of return was 7.47 and the other was way too high. It was 41%. And I apologize, I said 43, but it is 41%. Now, this assumption is too strong. It is sometimes unrealistic. Okay, if the IRR is substantially higher than the MARR, okay, that is unrealistic. Okay, PW and AW, on the other hand, my assumption is that all the positive cash flows I can reinvest it at my minimum attractive rate of return. That's a very realistic assumption. Okay, so one of the drawbacks of IRR is that the built-in assumption in IRR is that I can reinvest my positive cash flows at IRR. So for very high IRRs, this is a very unrealistic assumption. Okay, I hope you understood this point. So let's say if that is the situation, then IRR value is not a good basis for decision making. Apologize. So it's not a good basis for decision making. So instead, we can use PW and AW for our analysis. Okay, different procedure for multiple alternative evaluations. Now, to correctly use the IRR method to choose from 2 or more mutually exclusive alternatives requires an incremental analysis. And do not worry about this type of analysis because we will cover it in the next chapter. Okay, so let's move forward. Now, how do we know that there exists a situation where we have multiple IRRs? Okay, we can simply have a look at the cash flow diagram, at the cash flow series, and we can tell whether we have multiple IRRs or whether we have only a unique IRR. Okay, so let's focus on this. This one is very, very important, so please focus on this slide. When signs of the net cash flows changes only once in a cash flow series, it is called a conventional or a simple cash flow series. When signs of the net cash flows changes more than once, series is called non-conventional. So for example, let's say I start initially with a cash outflow. So the sign of my first cash flow is negative, okay, which means a series like this, okay. Okay, and then of course I have positive inflows. So how many times did the sign change? Only once, because it started with minus sign and there was, so year number 1 was the time when the sign changed. So there was only one change. Now see, the cash flow started in year number 0, 1 and 2 as negative, and the first change was here. Okay, so again there is only one change. Cash flow started with positive, it's a cash inflow, and then I have outflows in year number 5 and year number 6. Again, there is only one change because the sign changed in year number 5 and then it did not change. Okay, so again, one sign change. So whenever we have only one sign change, the cash flow series itself, it's called conventional series. But assume a situation where there is a cash outflow, like it started negatively, it changed in year number 1, so that is the first change. Here no change, so 0 change, 0 change, and there is another change here, and then 0 change and 0 change. So the total number of changes is 2. Let's focus on this one. It started positively. Okay, so this is the first change. No change, no change. There is one change at t equal to 5, and then no change at t equal to 6. Okay, how do I see the change? You have to compare the current year with the previous year and see whether the sign changed or not. Okay, so we have only 2 changes in this cash flow series. In the last cash flow series, it started negatively. So there is the first change in year number 1, second change in year number 2, no change here, change again, no change, and no change. And as you can see, it's 1, 2, and 3. So total number of changes is 3. So a cash flow series which has more than one sign changes, it is like a non-conventional series. For a non-conventional series, we have, when there is a more than one sign change in the net cash flows, it is possible that there will be multiple I values. Okay, and there is some criteria for it. We will learn about those criteria. So the key takeaway from the previous slide is that if there are more than one sign change, there are multiple IRRs. Okay, if there are more than one sign change, there are multiple IRRs. Now, how do we find multiple IRR values in cash flows? There are some tests. Okay, so test number 1, Descartes' rule of signs. So the total number of real IRRs root is less than or equal to the number of sign changes in the net cash flow series. So let me go back to the previous slide. So for example, if there are 2 sign changes, okay, there are potentially up to 2 IRRs. Okay, in the last example, there are potentially 3 IRRs. Okay, so the number of real roots, okay, corresponds to the number of changes. Okay, so the number of real roots is equal to or less than the number of sign changes. This is what Descartes' rule says. Another test, which is test number 2, Nordstrom criterion. If the cumulative net cash flow starts off negatively, so it must start negatively. Okay, so the first cash flow has to be a cash outflow, okay, represented by a downward arrow, and has only one sign change. There is only one positive root. Okay, although these tests look a little bit complicated, once we implement those tests in an example, they are straightforward, nothing complicated. Now Nordstrom criteria says if the cumulative, so please pay attention to this word, it has to be cumulative net cash flow. It has to start negatively, and let's say if there is only one sign change in the cumulative net cash flow, there is only one positive root. Okay, could have, let's say, two root values at which PW equal to 0, but positive will be only one. So that is something really, really important. Okay, so let me recap it for you. Nordstrom criteria states if the cumulative net cash flow starts negatively and has only one sign change, so the sign changes only once, there is only one positive root. Okay, so the positive root will be only one. There will be a unique, put it that way, there will be a unique positive root. Okay, but within the bracket it says that of course there may be multiple roots, but the positive will be only one, the others will be negative, of course. With the results of these two tests, the IRR relation is solved for either unique interest or multiple interests. Okay, something very important now. If the cumulative net cash flow starts positively, okay, and if you compare it with the previous slide, it says that the Nordstrom criteria is only valid if it starts negatively. Okay, so what if, let's say, a cumulative net cash flow starts positively instead of negative? Then test number 2 is not applicable. Okay, similarly, if the cumulative net cash flow starts negatively and has more than one sign change, then test number 2, Nordstrom criteria is not applicable too. Okay, because if there is only one sign change, we are sure that there is only one positive, there is at least one positive root. But there are, let's say, if there are more sign changes, we are not sure about that. So that's why the Nordstrom criteria is not applicable in that case. Let's focus on this example now, okay? And let's relate it to whatever we learned on the previous slides. Now, this is a typical example of multiple I values, okay? So determine the maximum number of I values for the cash flow, okay? So these are the net cash flows. At t equal to 0, there is initial cash outflow of minus 400,000, an annuity of $75,000 up to year number 9, and then in year number 10, minus 225. I think this one is coming from example 7.3. Okay, page 181. Okay, so as you can see, the project started with an initial investment of minus 400,000. Okay, so the cumulative net cash flow is minus $400,000. Okay, after an inflow of $75,000, the net cash flow is 325. Okay, so my task is to put all the cash flows and then calculate the cumulative net cash flow. Okay, and as you can see, it started negatively and it changed sign here, right here. Okay, so this was the first sign change in cumulative net cash flows. So let's try to find out a solution for this, okay, and see whether it passes test number 1. So for test number 1, we are concerned about the net cash flow. So test number 1 is based on net cash flow, and let's see how many sign changes does it have. So it started negatively, The first sign change was in year number 1. Okay, no change, no change, no change, and then the second change is in year number 2. So this was the second change. So the number of changes in net cash flow is equal to 2. Now let's go to test number 2. So what does it mean if there are 2 sign changes? It means that the number of real roots, or let's call it solutions. So the number of real solutions is less than or equal to 2. Okay, so we may have 2 solutions. Put it that way. Easy words. Okay, the number of sign changes is 2. So the number of possible solution is 2. Test number 2. Test number 2 is based on cumulative net cash flows. Okay, so as you can see, the cumulative net cash flows has only 1 sign change. Okay, here. Okay, therefore there is only one I value that is positive. Okay, because the Nordstrom criteria, what it says, that if a net cash flow, the cumulative, if it starts negatively and if it has only 1 sign change, it means that there is at least one unique positive IRR. Not at least, sorry, I apologize for my language. There is only one I value that is positive. Okay, so let me recap it for you. The Nordstrom criteria says that if the cumulative net cash flows started negatively, and if there is only 1 sign change, it means that there is one positive solution. Okay, if you plot all these numbers in Microsoft Excel and calculate the IRR, one IRR is 4.53 and the second IRR is minus 18.70. Okay, and it fits the Nordstrom criteria because, as we can see, we established that there is one positive IRR, and we can see that one is positive and one is negative. Okay, so we have two solutions, which is consistent with Descartes' rule, which says that the number of sign changes in net cash flow, let's say if it is 2, then the number of solution is also 2. And so we have 2 solutions. So 2 sign changes here, one is here, one is here, and that's why we have 2 solutions. Okay. Nordstrom criteria says if it starts, the cumulative net cash flow, if it starts negatively, and if there is only 1 change in the sign, there is one positive solution, which is here, the plus 4.53. Okay. Now, what is the criteria? Whenever we have, when it passes, let's say test number 1, test number 2, and we have one positive solution, the other one is negative solution, what do we do? If both calculated IRRs are negative, discard both of them. If both of them are positive, again discard both of them. If one is negative and the other one is positive, just like in this example, one is positive and the other one is negative, okay, use the positive IRR. So in this situation, we will use 4.53. So this is a simple, these are simple guidelines for multiple IRR values. In case 1 and 2, you need to solve the problem of multiple IRR values, of course. In case 3, you need to calculate the positive value, and you can confirm from test number 2. That's super easy. Now, how do we solve for multiple IRRs problems? Of course, if we have multiple IRR problems, I have to choose one rate. I cannot go with multiple rates. For project selection, I have to choose one. Okay, so how do we choose that? Multiple IRR problems can be solved by using additional information. So whenever we have a situation where we have multiple IRRs, we need additional information. That information, the reason I call it additional information, because those information are not given in the cash flow. And these are what they call outside information. That is why if I use additional information and I calculate an internal rate of return, that internal rate of return is called external rate of return. Why is it called external? Because I'm using some external information. Okay, therefore, ERR refers to IRR that had two values and are converted into single value using some additional external information. Okay, so for example, if you remember, I started with a slide. Let me go back actually. I'll actually not go back. So let's let me go back. I can do that. Okay. So if you focus on this example, I have two IRRs. One of the IRR is 7.47 and the other IRR is 41.35. Now the guideline says if I have both positive IRRs, I have to reject both of them. Okay, but of course at the end of the day I have to come up with an internal rate of return. So what do? I use some external information and convert these two IRRs into a single IRR. Okay, and that single IRR is called the EIRR because that one is externally, because in calculating that IRR, I'm using some external information which is outside of the cash flow. Okay, what additional information do we need? Okay, we need investment rate and we need borrowing rate. Okay, so this is a typical, let's say, a cash flow diagram. Okay, so let's say 200K of cash and let's say 50K of inflow, another 50K of inflow, and let's say 80K of inflow, and let's say we have here an inflow of 150. Okay, so this is cash outflow. Okay, so whenever we have a cash flow diagram with some cash outflows and cash inflows, we can differentiate between the two types of cash flows. Like for example, this negative 200K, what it really means that I have to borrow this money in order to finance this project. The cash inflows, it means that this money is coming into my pocket. Okay, so once this money comes into my pocket, I have the opportunity to invest this money. Okay, so I use two different rates. Okay, for the positive cash flows, what I'm using investment rate. Okay, because I'm hoping that the positive net cash flows, I have the opportunity to invest that money. On the other hand, the negative cash flows, okay, which is like the outflows, I need that money to start, let's say, a certain project with. Okay, what do? We borrow that money from somewhere, either from the market, from the capital market through bonds, okay, or we go to the bank and borrow that money. So we are using external sources of financing. Okay, so what I'm really doing in order to address the problem of multiple IRRs, I'm using two different rates. One is investment rate and the other one is borrowing rate. I use that information and then I convert the multiple IRRs into a single rate. There are some techniques to it, simple techniques, very logical, so please do not worry about that. We will learn about those techniques in my next lecture. So solving multiple IRRs, what do we do? Multiple IRR values can be solved by calculating external rate of return. Okay, why external? Because we are using some external information. Okay, what were those external information? Information about financing rate, okay, the investment rate and the borrowing rate. And there are two approaches. One is called the modified rate of return, and the other one is called return on invested capital. Okay, in my next lecture we will cover both these techniques and will arrive at a single IRR. Okay, so in order to provide you a recap, today's whole lecture was regarding the existing of multiple IRRs. There was a decision criteria which says that, let's say, if both the calculated IRRs are positive or if both of them are negative, just reject it. But let's say if one IRR is positive and the other one is negative, pick the positive one. Okay, so we have a unique solution then. So let me write it down for you. It's a good recap. So what are the guidelines? If the calculated interest rate 1 is greater than 0 and the interest rate number 2 is also greater than 0, reject. Okay. Reject doesn't mean that we reject both of them. It means that actually we cannot use both of them. Okay, so we have to modify it. That's why we need a modified technique. Okay, if the rate, both of them are let's say negative, apologize, if both of them are negative, again don't choose any one of these. Okay, we will use a modified technique. But let's say if one of them is positive and the other one of them is negative, then choose positive. Okay, it means, what it really means, that we have a unique solution. Okay, and this is what we are looking for. We are looking for a unique solution. In the first two, we do not have a unique solution. Okay, in the second one, we have a unique solution. Please go through some exercises, go through the chapter. It has some useful examples. In the Descartes rule, we are focusing on net cash flows. In Nordstrom criteria, we are focusing on cumulative cash flows. Okay, so please keep that distinction in mind. Okay, the Descartes rule says that if there are more than one sign change, so suppose if there are two changes in the net cash flows, and from changes I mean the sign changes, so there are two solutions. Okay, if there are three sign changes, so there are three solutions. Okay, on the other hand, Nordstrom criteria says that if a cumulative cash flow starts with a negative sign and it has only one sign change, it means that there is one positive solution. Okay, there is only one positive solution. I will stop here. Although today's lecture looks a little bit complicated, but to be honest with you, once you read through the book, once you read, solve some of the examples, it is straightforward. There is absolutely nothing technical about this material. So I will stop here. If you have any questions, please do not hesitate to email me those questions. If it is something related with the administration, please contact Ms. Sabahat. I thank you very much for your attention. Have a wonderful day.